Dear student, in previous class I discussed about the isomers. Isomers are of two types, structural isomer and stereoisomer. Stereoisomer, I discussed in the previous class about structural, different type of structural isomers with example. Now here I discussed about the stereoisomers. Stereoisomers are of two types. So one is configurational isomer and the another is conformational isomer. Configurational isomer is generally of two types, geometrical isomer and one is optical isomer. Geometrical isomer generally show that geometrical isomer are of two types, one is cis and the other is trans. There are some example of geometrical isomer or cis trans isomer, such as one example is 2-butene. Here in 2-butene, C double bond C, CH3H and HCH3. This is 2-butene. 4 number of carbon atom present, so it is but, and double bond is present in 2 positions, so it is called 2-butene. Here in case of 2-butene there are two types of isomer. The similar groups are in same side, that is called a cis isomer, and if the similar group are in opposite side, that is called trans isomer. It is a trans isomer. Here another example is malic acid and fumaric acid. In malic acid such as CHCOOH double bond CHCOOH. Here this 2 COOH group, a similar group hydrogen, is in the same direction, that is in upper direction, or the COH is in same direction, so it is called a cis product and it is called malic acid. And the fumaric acid, another is trans product. Fumaric acid means here fumaric acid C double bond C H COOH and COOH. This is an example of trans isomer, and here it is called fumaric acid. So cis and trans we can. Here cis is called also a Z and trans is called a E isomer. Here the example of another example of E and Z isomer is CH3CH double bond C, CH double bond CH2 and C triple bond CH. Here there is no similar atoms which are in opposite direction or same direction. Here it is to be seen that in case of CH3 and H you have to calculate this priority order. In case of H and CH3, that is the number of atomic number. Here CH3 and between CH3 and H, CH3 is in highest priority order than hydrogen, and in case of CH double bond CH to C triple bond CH, here it is in just imaginary parts. Double bond present means C double bond C means here C bonded to 2C. Double bond means C bonded to 2C. Triple bond means C bonded to 3C. So among between the double bond and triple bond, double bond is lowest in priority order and triple bond is highest in priority order, as the carbon attached to the 3C. So it is greater in priority order and it is here lowest in priority order. So between 1 and 2, one is in upper direction and here one is in lower direction. Both are in anti-position or opposite direction. So opposite direction present, it is called trans. Here trans means E. So it is called an E isomer. And another is Z isomer or cis isomers if C triple bond C is in upper position and CH3 in the same direction. So then it is called a cis isomer. And here also you have to calculate the number of geometrical isomer. To find out the number of geometrical isomer, there is some formula present. Number of geometrical isomer, you have to find out at first whether the terminal carbons are same in number of same atom present or not, or different atom present. If the terminal carbons are different in number of atom present, carbons different atom present, and n is equal to, n means number of double bond present is even number, then number of geometrical isomer is 2 to the power n. You have to understand these lines. Terminal carbons are different atom present, and n is equal to even number of double bond, so the geometrical isomer is 2 to the power n. At first I just understand you these terms in an example. That is, example is CH3 CH double bond C H CH2 CH double bond C CH2 CH3, and here is H. Here number of double bond is even, that is 2, n is equal to 2. And if the terminal carbons are different, that is, one is CH3 present and another is C2H5 or ethyl group, one is methyl group and another is ethyl group, then these two terminal carbons are different. And if different and number of double bond is even, that is here n is equal to 2, so geometrical isomer is 2 to the power n, means 2 to the power 2. Here it is 4 number of geometrical isomer present, and 4 number of geometrical isomers are here this CH3 and CH2. That is, in case of one double bond you have to find out whether it is E or Z, and another double bond it is E or Z. In case of this double bond, CH3 is 1 in position, and between H and CH2 group it is a priority first. So this priority 1 group is in opposite direction, that is called a trans. Here in case of trans it is E, here it is E, and 1 2 3 4 5 6 7 8 it is 2E, it is 2E, and the a double bond present in 5 position, so the 5 is, it is also 1 here is below, and another is 1 priority order between H and ethyl group is ethyl group first, so this 1 is at anti position or opposite direction, so it is also called a trans. Trans means E. So it is an example of 2E 5E. Whether you have to draw a structure of 2Z 5Z or 2E 5Z or 5E 2Z, different type of isomer, that is 4 number of isomers present here. One is 2Z 5Z, 2Z 5Z. Z means here cis isomers. These two double bond is in the configuration of cis, that is CH3 CH, double bond C H CH2 CH double bond C H CH2 CH3. Here these double bond, these two groups are present in the same direction, so it is called cis or a Z isomer, and this, that is 2Z, and here these two groups are in same position, so it is same direction, so it is also a Z, it is 5Z. So it is an example of cis, the 2Z 5Z, and another is 2Z 5E, and another is 2E 5Z. So there are 4 number of isomers, that is geometrical isomer present in case of terminals are different and the number of double bond is even. Here another part is, if the terminal carbon atoms are same and the number of in, that is double bond, is even or it is odd. Number of the terminal atoms are atoms are same, that is here terminal carbons are same, and if the number of double bond is even or number of double bond is odd. If n is even, so the number of geometrical isomer is 2 to the power n minus 1 plus 2 to the power n minus 2 by 2. Number of geometrical isomer is 2 to the power n minus 1 plus 2 to the power n minus 2 by 2. Such as one example is even, n is even and the terminals are same. The example is CH3CH double bond C H CH2 CH double bond C CH3H. Here number of double bond is 2 and the terminal is same, that is terminal is CH3 here also is CH3, and the number of double bond here is 2, that is even number of double bond present. So number of isomers here, if we put n is equal to 2 to the power n minus 1 means 2 minus 1 plus 2 to the power 2 minus 2 by 2, that is 2 to the power 2 minus 1 means 2 to the power 1 means 2 plus 2 to the power 0 means 1, that is total number of isomers is here 3. In case of this type of compound where terminals are same and the number of double bond is even, total number of geometrical isomer formed is here 3. And it is also seen that if the terminal atoms are same and n is odd, if n is equal to odd, then number of geometrical isomer is 2 to the power n minus 1 plus 2 to the power n minus 1 by 2. Between cis and trans isomers, cis isomer has a high boiling point due to presence of dipole moment. As dipole moment present, so its for attraction between these two molecules increases, and to break the bond between these molecules, that is the boiling point also increases. But in case of trans isomer, the melting point is high because due to the packaging, well packaged of trans isomer, so its melting point is high. Here for syn and anti isomer, in case of syn, that is for example benzyl loxime means benzaldehyde, when benzaldehyde CHO in case of benzyl loxime, that is benzaldehyde when with hydroxylamine means NH2OH. It is a one type of condensation reaction where H2O released, that is benzene ring CH double bond NOH, that is called benzaldehyde and hydroxylamine reacts to release water. It is one type of condensation reaction and forms benzyl loxime. Here benzene ring and CH double bond N, lone electron pair, and OH. In case of benzyl loxime, we have to consider the positions of H and OH. Here H and OH is at the same direction or same direction, so it is called syn benzyl loxime, and one is anti-benzyl loxime, that is PH CH double bond N OH and lone electron pair. Here H and OH, these two groups are anti to each other, so it is called anti-benzyl loxime. And in case of a ketoxime, let us consider in case of any type of ketoxime, that is C2H5 single bond C CH3 double bond N OH. In case of any type of ketoxime, you have to consider with respect to OH. With respect to OH, CH3 group is in syn position. Here CH3 is syn to OH and C2H5, that is ethyl group, is anti to OH. So its name is here syn in case of with respect to OH, syn is CH3. CH3 is at situation, so syn methyl ethyl ketoxin. Or it is to be written as anti with respect to OH. C2H5 is anti with respect to OH, so anti ethyl methyl ketoxin. Here it is to consider that with respect to OH, and the another is exo and endo. Here let us take an example here. These two groups, it is and COOH, between them COH is priority, its priority is 1. So these two groups are same direction, so it is called an exo, and another where COOH and these groups are anti to each other is called endo. Endo product. It is endo and it is called exo.